Okay, so today we're going to conclude or finish up with our inverse trig functions, and we're looking at the relationships. So our learning intention is obviously the relationships of inverse trig functions, and we'll be successful if we can recall these relationships. So sine of inverse sine x, or sine of arc sine x, is going to equal x only if the arc sine of the inverse is defined between -1 and 1. Same as the cos, so cos of the arc cos of x will equal x only if inverse cos of x is defined between -1 and 1. And tan of the arc tan of x equals x only if arc tan is defined for all real values of x. Now, obviously, they're the normal trig ratios, and then the arc sines are inside, the arc versions are inside, and here now the arc versions are outside, and the normal trig ones are inside. So an arc sine of x equals x between negative pi and 2 to pi on 2. For arc cos of x is defined for 0 to pi, and arc tan equals tan of x for pi on 2 to pi on 2, so negative pi on 2 to pi on 2. Let's do some examples. Okay, so here we've got sine on the outside and arc cos 3/5. So what we want to do is we actually want to do the inside part first. So if we do that, so we've got cos, so arc cos is 3/5. I'm going to put x on the outside. So what that means is cos of x equals 3/5. Yeah, so I've brought that x that I've introduced inside, and then took the angle onto the outside. So what it means is, what angle is x? Now it's a cos function, so what I do is I draw a right angle triangle. I then go, my adjacent is 3, my hypotenuse is 5. Using Pythagoras' theorem, I can figure out that this is 4. So 4 squared plus 3 squared equals 25. Square root of 25 is 5, okay? And so the sine, so now we look at the fact that the sine, we want sine of x. And what is that? Well, that is opposite over adjacent. So that actually equals 4/5. So the answer to sine of inverse cos of 3/5 is 4/5. Okay. Now let's do tan of arctan 5/13. So if I write the inside part first, I've got arc sine is 5/13, and what that means that, let's say that equals x, that sine x equals 5/13. So I draw my triangle. There's my x. My opposite is 5. My hypotenuse is 13. And now I want to figure out what my adjacent side is. So using Pythagoras, 13 squared minus 5 squared equals 144. So that's square root of that is 12. Okay. So really what I want to do is now figure out what tan x is. So that's yeah. So we want the tan of x, which is obviously 5/12. Yeah, so tan of arc sine 5/13 is 5/12. All right. So, same thing. So we've got inside part first. So arc sine of 2/3, let's say that equals x. So that sine x has to equal 2/3. I draw my triangle. That's my x. I've got sine, so I've got my opposite over my hypotenuse. Using Pythagoras, I want to find my adjacent. So 3 squared minus 2 squared is square root 5. So now I want to find what cos x is. Cos x. So cos x is going to be my adjacent over my hypotenuse. So that's going to be square root 5 over 3. So the solution to cos of sine, inverse sine of 2/3 is square root 5 over 3. Okay. So once again, we've got inside part, cos of inverse cos is negative 15 over 17. Okay, so that means cos of x equals negative 15 over 17. Okay, so this is a negative value, so it's going to technically be in the second quadrant. So let's say that's x. I've got my adjacent of 15 and my hypotenuse of 17. Okay, so using Pythagoras, 17 squared minus 15 squared is 64. So that's 8. Okay, now what I basically want to find what sine x is. So sine of x is 8 over 17, and sine is positive in this quadrant, so that's our solution. So sine of inverse cos of negative 15 over 17 is 8 over 17. Okay. So we're doing the inside part first. So inverse tan of negative 1/3. Let's say that equals x. So tan of x equals negative 1/3. Okay. So tan is negative in our inverse in the fourth quadrant. So let's say that was x. And now, so tan is negative 1 over 3. So opposite over adjacent, so negative 1 over 3. So 1 squared plus 3 squared, so that's square root 10. And we want to find what cos of x is. So cos of x is the opposite over the, so the adjacent over the hypotenuse. And what we're going to do is we're going to, let's make this a rational denominator. So the solution to cos negative tan, so inverse tan, is, you can write it as 3 square root 10, but as a rational denominator, we've got 3 square root 10 over 10. Okay. Last one for this example, we've got, so cos of negative 1 equals negative 3 equals x. Okay, so that actually means that cos of x has to be negative 3/4. So it's in the second quadrant. Okay, so my adjacent over my hypotenuse. And so using Pythagoras' theorem, 4 squared minus 3 squared, so square root 7. And so what we want is we want tan of x. So that's opposite over adjacent. So negative 7 over 3. So the solution to tan of cos negative 1, inverse cos of negative 3/4 is negative square root 7 over 3. Okay. So some more examples. So we're going to evaluate inverse cos of negative pi over 6. So let's do the inside part first. So we have cos of negative pi on 6. Okay, so we've got cos of negative pi on 6. So when I have this, I kind of look at my exact triangles. Because if I've got a pi on 6 or pi on 3 or pi on 4, that rings bells to exact triangles. And here's a copy of my exact triangles. So if I've got a pi on 6, that's equivalent to 30 degrees. And so the cos of that is going to be opposite over the cos is going to be opposite over adjacent. Adjacent over hypotenuse. So I've actually got cos of negative square root 3 over 2. And I know that if we're looking at this, so a negative degree is here, and cos is actually positive in this quadrant. So it is the same as square root 3 over 2. So arc cos of 3 over 2, let's say that equals x. So we want to find what cos of x is of 3 over 2. And we know that to be pi on 6. And that's the answer. All right. So next question, we've got arctan is of tan inverse 5 pi over 6. So we'll do the middle part first, the inside the brackets. So 5 pi on 6 equals x. Okay. Now, if you're better to work with degrees, we know that this is the same as this is the same as tan 150. So if I was to draw it, um, 180 minus 50 is 30. So really looking at this part here, and 30 we know as being at pi on 3. Okay, and we want to evaluate basically inverse tan of pi on 3, and the pi on 3 currently is, looking at my pi on 3, I've got 1 square root 3. So, so the tan is 3 opposite over adjacent. So we've got x equals pi on 3. However, we're in the second quadrant. Okay, sorry, it wasn't. It's actually 30 degrees, so 30 degrees is equivalent to pi on 6. So pi on 6 is with using our exact triangles. Yeah, we have 2 and we have square root 3 and 1. So the tan of this becomes opposite over adjacent. Yep. And if that's x, so we want to figure out what tan x is if it's going to be negative 1 on 3, because we're in the second quadrant. So it's going to be pi on 6, and that's the solution for that. Okay. All right, so now we have some more examples. 4 pi on 3. So 4 pi on 3 is equivalent to 240 degrees. So it is here. So if I minus, okay, so this is 60 degrees, so that's the same as pi on 3. Using our exact triangles, we have unit of 1, hypotenuse of 2, and opposite of 3. So we know that we're trying to find arc sine of, so the sine of pi on 3, which is square root 3 over 2. So sine, of negative 3 on 2. So sine of x equals negative 3 on 2. So that's going to be negative pi on 3. So we're going to do the first part first. So we want to find cos of negative pi on 4. So we're currently working, it's a negative angle, so we're currently working in the second quadrant. And pi on 4, we get so negative 1 over 2. So we actually want inverse cos of 1 on, so negative 1 on 2. So what is cos x of negative 1/2? Well, we can look at our our graph. So negative a half works out to be somewhere here, which is technically, using still our exact triangles of 1 over 2 is pi on 4. Okay. So here we've got 5 pi over 6. So if we want to use degrees, we've got 150. So what we have, pi on 6 here, because that's going to be 30 degrees. Using our exact triangles, we have pi on 6, so it will look like that. So we get square root 3, 2 and 1. Yeah, so we actually get, what we have is got arctan of, so this is tan, so 1 over 3. It's negative on this quadrant. So we get, let's make that x. So tan x equals negative 1 over square root 3. Well, that's going to be negative pi on 6. Let's answer that part. All right, so we have cos of 5 pi over 4 using, that's 225. So that's going to be somewhere here. So it's going to be 45, so that's going to be pi on 4. And we have 1, 1 and 2. So we actually have cos, so that's square root 2, of negative 1 over square root 2 is x, so cos x equals negative 1 over square root 2. And so x in this point is going to be pi over 4. However, because it's a function, we should only get one solution. We use the fact that we want pi minus x. So pi minus pi on 4 becomes 4 pi over 4 minus pi on 4. And so what we get is we actually get 3 pi over 4 as our solution. Okay, so here we get sine of pi on 4 and arc sine. I'm going to use this property that inverse sine of sine x will equal x for pi over 2. And so technically pi and 4 is between this range, so using this property we should get pi on 4 for that solution. Okay, I'll do one more example. I'll do arc tan of 3 tan 7 pi on 6. Okay, so I'm just going to worry about this part. So 7 over 6 times 180 is 210. Okay, so we have something over here. So that's going to be pi on 6. Okay, so we've got tan so this is going to be 1 square root 3 and 2, so it's going to be tan of 1 over 3, but we've got 3 lots of that, so we're actually going to times this by 3. So we get 3 over square root 3, and then if I want to rationalize the denominator, multiply with square root 3 each way, gives me 3 square root 3 over 3, just ends up being square root 3. Okay, that's figuring out that this is obviously 210, so minus in 180 gives me 30, so pi on 6. The tan of this is opposite over adjacent, so 1 over square root 3. I'm going to multiply by 3 because that's 3 times as big. So now we want what is tan of square root, what is inverse tan of square root 3. So tan x equals square root 3. So if we think about it, it's the opposite over adjacent. So the solution will be this opposite angle, so opposite over adjacent becomes pi over square root, pi over 3. Okay. Just to finish off, just as some interest, if you wanted to know the graphs, this is obviously arc sine of sine x, or written as that's that graph. If we wanted arc cos or inverse cos of cos x, we get the similar graph but moved between 0 and pi. Yeah, so here, as you can tell, this is pi on 2, and this is negative pi on 2. And finally, we get inverse tan or arctan of tan x. Okay, and that's it. Thank you very much.